So in the distributed consensus, we have seen how it works and what are the basic requirements for the distributed consensus that we have seen in the previous lecture. So as we know that why we are using this consensus in the distributed network, that means the consensus algorithm that allows a collection of machines to work as a coherent group that can survive the failure of some of its members in that. So in that case, it is very important in the distributed system that if any one of the server goes down, the remaining server should take off that responsibility so that the network continues. So that is the basic motto of your consensus algorithm. So then we have seen that for distributed consensus in the permissioned blockchain model or permissioned blockchain system, one is Paxos, another one is your Raft. In the previous lecture, we have seen the Paxos, how it works. So this Paxos is based on your current standard for both the teaching and implementation consensus algorithm, and very difficult to understand and very hard to implement these Paxos algorithms. Why? Because every server has to maintain the status of your replicated, and every time they need to compute their the unique ID by using your hash algorithm to give the security process. So those few things which we have observed. So the idea behind this, the Raft protocol, which was designed and presented in the year 2014 by an author, the idea behind this Raft consensus algorithm is that the nodes we call the server computers in the network. Suppose if you have one or two nodes are there, and if they are peer-to-peer connected nodes in that, let us see the node 1, node 2, or node 3, and suppose node 4. So this algorithm concept is the nodes collectively select a leader first. They try to select a leader among themselves, and the remaining nodes become the followers of these nodes. If any one node is selected as a leader, the remaining nodes become the followers. We'll talk what is a job of this. So the leader is responsible for state transition, log replication across the followers under the closed distributed environment. So assuming that all the nodes are trustworthy and have no malicious intent in this network. Suppose there are 4 nodes are there as a cluster, they are trustworthy to each other. So the basic idea of Raft came from the fact that in a distributed environment, we can come to a consensus based on Paxos algorithm and elect a leader, which we have seen in the Paxos algorithm to elect a leader. So interestingly, if we have a leader in the system, we can avoid multiple proposers proposing something the altogether in that Paxos, like proposer will propose and that request goes to all the acceptors, and based on the majority of your acceptors, the value is selected, and based on that value, every proposer or acceptor become the learner in Paxos. So that activity is there. So in that we also seen that there are multiple proposers, so they can propose at a time sometimes. So then there will be difficulties to identify. If the 50% of the acceptors are there, in that case also your Paxos algorithm is difficult to decide whether to go with one group of people or go with the another group of people. So there we have seen in any faulty there must be 2f plus 1, acceptor should required so that that algorithm works. So in the case of the Paxos, we don't have any the straightforward mechanism to elect a leader there. So, however, to elect a leader, the multiple proposers propose the thing simultaneously, and consequently, the protocol becomes the complex then, and the acceptors have to accept one of the proposal from the proposer. So in that case, we use the highest proposal number for the tie-breaking mechanism, and embed a certain algorithm in Paxos to ensure that every proposal coming from a different proposer is unique. So thus, all these internal details make the Paxos more complicated. If there are n number of proposers are there, then n number of acceptor should respond to all those and decide to go with which proposer is a difficult task part. So in this distributed environment, and the under a synchronous assumption, that is the closed environment, so it is possible to design a consensus algorithm. So first we will elect a leader, and then the task of the leader to propose something inside the closed group. So there will be a single proposer, and all the acceptors are followers of that leader. So the whatever the leader is going to do, because here for leader the role is going to be defined. So in that case, every node will have only one leader for a period of time, and every other node becomes the follower of that. So by this basic concept behind this, the Raft, the algorithm is much better, or much easier compared to the Paxos, to reduce the complexity in that case. So how it is much easier means, first they understand, easier to understand this concept, and the several open source implementation is there compared to your Paxos. So we'll see that one by one. So it may be your Paxos, or it may be your the Raft algorithm. Okay, so both maintains the replicated state machine. They both maintain the replicated state machine that we have seen before your Paxos, that every closed group of your server, they have two status. One is they have the consensus module, as well as they have the state machine, or the replicated state machine. So every smart contract is executed by your state machine. If any new transaction is there, that will be executed by your state machine. So in this replicated state machine, why it allows a collection of servers or group of servers in the closed network, permission network, and they maintain the identical copies of the same data. If any transaction happens at any of one server, suppose, which have the consensus module as well as your state machine replica, if any input is there and if that is added to any of the ledger, suppose, then the entry of that transaction will be shared with all other closed servers, so that they can maintain the identical copies of the same data, and that will continue operating when some servers are go down, because that copy is still available with other servers in the network. So at any time, at any point of time, every server have the same copy, that is the updated copy. So in this replicated state machine, because of this, majority of your servers must be remain up. If any one server, because of the external problem or internal problem, external problem means because of any hardware problems it may go down, or because of software problem it may go down sometimes. So these replicated state machines are typically built around a distributed log first. So that log, whatever the log is prepared, replicated, the ledger or the log is prepared, that is distributed among all other servers so that they have the unique copy. So each server stores that log containing the command or your transaction. So any command or the transaction will be there. So that we can see in a replicated machine. Suppose in a closed network or closed group of your network, from there you have some n number of or few number of your clients are there, and from those clients a closed group of your servers are selected in the permission blockchain model as per your the Raft algorithm. So that servers, it may be they will have the consensus module as well as the state machine. That we have seen the state machine, they can change this, take some input and change the status based on that input, and it may go to the next state for that input side, go to this state, and finally they may reach to other state, that the final state we call represent the final state. So every any transaction is updated by any of the client in the network, that must be any one of the state, right? That is what we have observed in Paxos also. The first distributed consensus algorithm in the closed group. So in this case also, they have the consensus mechanism and the state machine of your closed group servers. So upon receiving any new transaction, so that transaction means that command should be executed by every server at a time, the same term or at the same time, so that the identical copy should be there. So for that, first that new transaction, before it is going to commit or add into your block, it is going to be added, share that information with other servers also. So upon receiving these servers, this transaction by other servers, they try to check whether this log is already there in the record or not. If this log is not there in the record, then try to add that log into the ledger or log file or log record. And once they add that new transaction into the log record, these are the existing one and this one is your new one. When they add, then once they add the new transaction into the log record, then they try to execute that log record by using your state machine, by following a state machine. So same, that is your smart contract type. So same copy is executed at every server, and once they are committed by adding this new transaction to your record, log record, and that information is exchanged among the servers, then it is going to be executed. And once it is executed, the state machine is executed, replicated state machine executed, that will be give the answer to the client that the transaction is successfully added. So in this, most important is the replicated log which is generated here. The replicated, that is going to replicated in every state machine. So all the servers execute the same commands in the same order. Same commands in the same order, or same transactions in the same order. That means if the first record is X assigned a value suppose 3 and Y assigned a value suppose 2 and X assigned a value suppose 1. Okay. So this record must be same at every server. So there is a sequence and the same order will be maintained to execute that. So that is the concept of your rafter. And then once this transaction is added, as said, the consensus module ensures the proper log replication, that every server in the network in closed group, they have the same identical copy. Once they confirm, then they try to execute the state machine, the replicated state machine, and that response will be given back to your client. So this is the state machine or replicated state machine, which we already discussed, but want to recall that one. So in distributed ledger, as we are saying, in this case, another important basic point is distributed ledger in the replication machine, replicated state machine. So the state machines always executes the commands or your transactions in the log order, as we saw in the previous case. So same order means if there is a transaction 1, transaction 2, transaction 3, the same log record will be executed by all the other machines. It should not like transaction 1, then transaction 3 and transaction 2. So this log record is rejected or ignored. So this in the log order, then when state machines executes those transactions in the log order, they will remain consistent as long as the command or transaction execution have the deterministic results. So the system makes progress as long as the majority of your servers are up. And if any server goes fail, or if it is failure model is there, then that fail is stopped is because of the delayed messages or lost messages when they are exchanging the information from one server to another server, but not because of the Byzantine. Why? We are assuming that all the servers in this the Raft consensus algorithm are trustworthy. So the connection between the nodes, maybe it may, some connection or may be fast. The bandwidth may be fast, and the bandwidth between this node to this node may be your slower one, or sometimes the connection may be disconnected. So because of that, whatever the information, the log order which is executing, that may be missed out. But other nodes have the updated copy. So once it is again connected into any server which goes down or failure model, if it is connected to the network, then they will sense with the other nodes whether the same log order is going on or any new order is there. Means new transaction is added and new log record is circulated among the within the network. So that is the distributed ledger information. Then to understand the basic objective of your the Raft algorithm, whenever possible, this Raft algorithm that select the alternative that is the easiest to understand, that if any server goes down, the alternate server will be take a responsibility for after waiting a random period of time that we will discuss. So what is the basic technique that were used in this Raft means this system startup and has a set of follower nodes. So the follower nodes, look for a leader. So if a timeout happens, then there is no leader and there is a need to elect a leader in the system. A few candidates stand for a leader in the election process and the remaining nodes vote for the candidate. So the candidate who receive the majority votes become the leader, and the leader propose a proposal and the followers can either vote for or against that proposal, and they exactly only one time. So in this case, the technique is used that the entire the concept is that includes it divides the problem into the smaller problems first. That is, it starts with electing the leader and then giving role to the leader, and then everyone become the followers type. Then that reduce the number of system states to consider by just considering only one leader's the log record. So that concept, it is having three basic mechanism in the overview, that every server in the network, they may be in any one of the state. First state is leader selection state, as you said. So in leader selection state, they select one of the server to act as a cluster leader or cluster head, we say. Okay, and once they select this leader, they detects all the responsibility will be taken by the cluster leader only. That adding new transactions and informing all other servers. Once they update their transaction log records, then start executing. So frequently the other nodes in the network, they try to listen to the leader who is elected here. So then sometimes the elected or cluster head may detect some crashes in that because of the hardware problem or because of the software issues. Then the other nodes, those who are still active in the network, they try to choose a new leader to take the responsibility. Then another one is the log replication. Suppose if any server or any node is successfully selected as a leader for a period of time, then that leader roles and responsibility is defined. What is the role and responsibility means? The log replication process. That is the normal operation. So the leader takes the command or your transactions from their clients and append them to its log record. And once append them to in the log record, the leader replicates its log, and that log is try to replicates to other servers also by overwriting the inconsistencies. So that is the once elected as a leader, the basic operation, normal operation is collect the transactions from the clients, build a new log record, replicated record, and share that new replicated record with other servers in the network. So that the clients, those who are connected to those servers, they will also have the new transaction records. Okay. So then comes to your safety. So only a server with an update log to achieve this safety property in we have seen it in FLP, that safety is more important, that it must have every server in the network should have the updated block or updated log record in this case. So only a server with an update up to date log can become the leader. So this is the basic concept of your Raft overview. So in this case, as an example from the database replication, we have distributed multiple replicated servers as we saw in this case. So any one server, if this server becomes the leader, elected as a leader, then this leader, okay, if this server elected as a leader, then the remaining become your followers of that. So then only this leader will receive the transactions or command from their clients, and that will be added to your the log records, and then they start executing the state machine, and this process is continued in this. So let us see that as the servers, the Raft clusters consist of several servers. Typically 5 servers will be there. Okay, so each server can be in one of 3 states, either in leader state, or in follower state or the candidate state. Any one of this. Okay. So the candidate state means to become what you call the leader or in the competition. Okay, yeah.
So, and candidates, as we know right now, their only requirement is to have the up-to-date list of everything.
Correct. Yeah. Yeah. So here the the followers are there, just the passive one. Simply they reply to the request coming from their leader. So that means if any one server one is suppose elected as a leader, okay, then whatever the request comes from that server, all the remaining servers they become the followers. Server 2, suppose server 3 and server 4, they simply respond to these requests. So what request it comes in the form of this request means your selected leader is going to share the updated block record, the replicated state machine record, right? So for that they try to update it and gives the response, yes, our log record is updated. So for that is the only activity done by these followers. Okay. So let us see that the server states any one leader. So that is electing your leader. So we are saying that the servers are any of these following states. So what happens when it starts up? When the server or network is start up, every server is in the follower state. Every server is in the follower state. Okay. So how much time they wait for the they will be in the follower state means for a random period of time, short duration of time. That means we also say this follower state as you are listening to the network. If everyone is newly connected to the network, suppose, so no one knows who is the current leader. So as soon as they join the network, they wait for a random period of time and check whether any server is active or not in that. So after that, if any server is not active, when it times out, the random period of time they'll wait. When it times out, then any one server in this, they start the election process. They start the election process. That means they send the request to other nodes. I want to become a leader. Okay, start election process. When the candidate starts sending a request to become a leader, that state become from follower to your candidate state, candidate for your leader position. Okay, so during this time, the candidate may also receive some other candidates new election request also. So then wait for a random period of time for the response from other servers to the election request which is proposed by the follower here. And once the majority votes received by your follower, by the candidate, then the transition change from candidate position to your leader position. So once a leader is elected, then the leader will discovers the server with the higher term and respond to the other, all others become the followers and try to respond with that the higher term or higher what you call the response from the leader. We call that as your heartbreak. Okay. So then during this candidate state, as we said, the candidate may discover the current leader or new leader, then the candidate become the follower. The candidate become the follower. So this is the part of the electing the leader or voting request. So the first part of your raft is to elect a leader. So and for that, there should be some leader candidates. The nodes sense the network, and if there is no leader candidate, then one of the node will announce that I want to be a leader. So the leader candidate requests the vote, and this voting request contains two parameters. One is the term, and another one is the index. That request consists of one is term and index, or that request packet consists of one is the index, another one is your term, or we can call the time or nuns in that. So this term is the last calculated number known to the candidate, and index is committed transactions available to the candidates. So this algorithm works with multiple rounds, and the term indicates a new voting round. If the last voting finishes, then the next term will be the old term number plus 1. So the index indicates the committed transactions available to the candidate. So it is just like increasing number to the distinguish between already committed and the new transactions. So let us see what do you mean by the term. Means, as said, the epoch of any arbitrary length time. So it starts with the election of your a leader and ends this term when the leader becomes unavailable or no leader can be selected. That means there is a split. The split vote in that case. So different servers may observe these transition between terms at a different time or even miss them. Different time or miss them, or different time intervals. So what will be there in this term means, first the election process will be there in that term, and second one is your normal operation or your what you call the index part. So here you can, from this term you can see this term is, or the time for any leader or follower is entirely in a random number. The random time selection. Okay, so some leaders may get a smaller amount of time to work as a leader. Some may get the highest term, and sometimes none of the servers or nodes in the network proposed any election request. In that case, no emerging leader is there during that time. So everyone become idle, and everyone can try to send a request for to become a leader. So this is the basic concept of election for your leader or electing a leader. So how these messages are exchanged? So it is the Raft basic. This Raft consensus algorithm use the remote procedure call, which any system, any single workstation, it wants to communicate with any other processor, any other process. They can use the simple, protocol to exchange or communicate with other processes. Use this RFC remote procedure call. So this is the same remote procedure call is used to communicate with the other servers also. So these servers basically communicate through the RFC remote procedure call. So when this protocol is required means during the request a vote and append the entry into the log record. So for requesting vote and getting the response for this vote and adding the new transaction into your log or new log entry into a replicated state machine, will use this remote procedure call for updating the records. So what will be there by using this remote procedure call? The server, any of the server who is there in the first order, that the follower order in the initial stage, okay, they will generate the request oath. In that request oath, you will have the term and the index. This will be broadcasted or sharing with other servers in the group. So that will be this root request oath is initiated by the candidate during the election. So once the request oath is initiated, the follower becomes the candidate. The follower becomes the candidate. And once the candidate gets the closer response, become the leaders. Right? So once become leader, second job is append the entry that is initiated by your leader to replicate the log entries and provide a form of that heartbeat by exchanging this information with other servers, and giving that the by providing this heartbeat message to the other servers indicates that your leader is still alive, means active in that. And the empty append entry calls will be given for the other users, so that it indicates that your leader is still alive in the network. So in the leader election process, as we said, the server starts with the being a follower, then remain the follower as long as the server receives the valid RPC from a leader or a candidate. So when a follower receives no communication over a period of time, the election times out, that is a random period of time, then it starts an election to pick a new leader. Any follower. But once the follower becomes your leader, suppose, there is a chance, as we said, because of the hardware problem or because of software problem, your leader may become fail. When your leader becomes fail, your leader cannot process the transaction which comes from your client. So then, when this leader become whether active or not, how to know? The followers notice at a different times the lack of your heartbeats. Wait for a random period of time. The other, the servers, they'll wait for a random period of time. If these servers are unable to receive any heartbeat from this leader, then they decided to elect a new leader, whoever the live are active in that network. So that is what given. If any leader is chosen, elected, then if that leader, because of hardware problem or your software issues, okay, if in that random period of time, if your follower 1 or follower 2, okay, if they are able to receive this, the last heartbeat from this leader, they assume that that will become your timeout and assume that your leader is inactive. When leader is inactive, then whoever the remaining followers are there in the network, they try to go for the election process to become a leader. So that is the followers with the shortest timeout, either A or B, they request to become the new leader to other active servers in the network. So you'll see this in the starting and election process. As we said, when the follower starts an election, because initially every node in the network, they don't know each other, so every are treated as your followers only. like 1, 2, 3, 4, and 5, suppose. So they try to sense the network. In sensing who is the current leader, by this sense they comes to know who is the current leader and what is the updated log record. And how much time they wait for some random amount of time, random period of time. After that, any one follower, they increment their status. They increment their term. Called the term means the time. Okay. So they increment its current term, and along with current term, the transition to the candidate state. Once the request is sent from any of the follower, they change their state from follower state to your candidate state. From follower to candidate. Then during this process, any of the follower, they vote for themselves also. The self-voting will also do. Okay. And then issues a root vote RPC in all other nodes in the network to all other servers in the cluster. This is the starting and election process. And then once that is done, then become as your acting as your candidate, from followers to become as your candidate. During candidate remains in the same state until that candidate wins the election. And if any other server becomes the new leader, in that time also the follower become the candidate until any other server become the leader. That means there is a possibility that in the same term, multiple servers may send a request to become a leader. In that case, during that period of time, it goes by with no winner. So that's why your follower become your the candidate state only. And once get the means majority of your votes or the proposer receives the majority of votes from other servers in that cluster for the same term, then become the winner of that particular term and become the leader. So each server will vote for at most one candidate only. This is very important in this. At most one. Whereas in Paxos, the acceptors can respond to multiple proposers. But in Rafta, during that election time, they can respond to at most only one candidate, not multiple candidates in a given term. So the first one to whom they are going to respond means the first request from where the follower is received. So the majority rule here ensures that at most one candidate can win the election, because at most only one response will have to give by the follower. Yeah.
In this case, if you are voting for the first node that contacts you, how do you get a set of nodes that each have contacted other nodes, and at this point, every node is voting for a leader or is voting somehow.
The follower, to respond, the follower follows first in, first out method.
Okay.
First in, first out method. Okay. First in, first out means for first request vote, you will respond.
Yeah.
So you can respond in either way. Either you may accept, you may reject.
Okay.
So if you accept, you deny all others' requests.
Okay. So that,
If you deny for the first one, you may choose anyone.
okay.
Yeah.
Thank you.
So the winner becomes the leader and sends the heartbeat messages to all the other servers to assert it's a new role. I'm the leader, elected as a leader. So the distributed log creation and distribution will be done by a leader in that network. So let us see this with this example. There are 5 servers are there in this cluster. These servers will be either any one of these states, either follower state or candidate state or your leader state. So initially, they are not known to each other. Means what is happening inside this network not known to anyone. So at term 1, during term 1, your server 1, server 2, server 3, 4, they all are treated as your followers. Correct? So then after that they will, every server, every follower in this network, they wait for a random time, random period. And in that random period, if they are unable to receive any of the request from any of the server or unable to receive any of the messages, in that case, anyone, the server 3 become try to become a leader. So the term is changed from 1 to 2. That is incremented. Term will be incremented. If none of the leaders are present in the network, then any one follower can increment their term and they add the new index and try to send a request to every other node in the network. So that request oath consists of your term 2. So upon receiving this request oath term 2 by other servers in that network, they update their term. So during the term 2, another server S1 is concurrently times out. That means whatever the random period that they have to wait as a follower, that time is over. So S1 is also trying to send the request oath with the same term. Now, upon receiving this term 2, every server in the network they update their term from 1 to your 2. Right. So now every node in this or every server in this cluster, they have 2 requests now. Okay. One request oath of 2 is from your server 3 and another is from your server 1, that is another request oath 2 is there. So now as per the concept of your Raft says that every node, every server in the network, they have to grant or they have to respond to only one request. Only one request. So in this case, your S5 granted to your S1 and S2 granted to your S3. Your S4 is also trying to give the grant to your S1, but while that grant is transmitting because of the fault or because of the crash, it may not reach to oh, it's time now. Okay, so it may not reach to your S1, right? So then when this S5 is granted to your S1, it must inform the other proposer that I am denying your request. So that information is given S1, S2 granted to S3, so denied to S1 request. Similarly, S5 and S6 granted to your S1, so denying to your S3. Similarly, S1 become as a leader, so denied to your S3. S3 wants to become as a leader, so denying to your S1. So in that case, neither candidate gets the majority in this situation. Then after a random delay between your 150 to 300 milliseconds, they try to go for the new process. That means what? They wait for another random period of time. When that random period of time becomes out, your S1 in this case is changing its term from 2 to 3, that is new increment, and that request is broadcasted among all others. So upon receiving this request, every other server they updated their term from 2 to 3. That is the new updated request for the leader. And then they try to respond or give their grant, suppose to your server 1. Then server 1 become the your leader. Your server 1 become the leader. So until they got the response from all other users, your server 1 become a candidate only, in the candidate state only. Okay. Upon receiving this response, your server 1 become the leader, and the all other agreed to server 1 as a leader, so they become the followers. So now it is the job of your server 1 to create the distributed lodge. Okay. So that is, then during this process, hearing from the other servers means what? The candidate may receive the append the entries to RPC from another server claiming to be a leader. So if the leader's term, that is your time, okay, is at greater than or equal to the candidate's term from your S3 in our example term, then the candidate recognizes that the leader and returns the follower state. Otherwise, the candidate ignores that RPC and remains in the candidate state to collect the other information, the updated information from other user servers. So during this election process, there will be a chance of your split election. So split election means what? No candidate obtained a majority of the votes, as we saw in this case. So none of the candidate got the majority of vote. So there it generates your split the vote, or split the election process. So that is the split election. No candidate obtains a majority of the votes in the server in the cluster. So each candidate will time out and start a new collection. They have to wait for. So it is just like in our mobile ad hoc networks, RPC is using. So carrier sends multiple access protocol type is used. So before sending any data into the network, they sense the common communication channel. If the channel is idle, then try to send the data. If channel is busy, wait for a random period of time until you get the chance. That is. So each candidate will wait out and start a new election, and after incrementing its term number. That is 1 to 2, 2 to 3, 3 to 4, and so. So how to avoid this split election means the Raft uses the randomized election timeouts. As we saw in this case, some term may have the less time for your election process. This time for your election process remaining is your normal operation, and some term may have the bigger time. This is for your election process, and this is for your normal operation. So wait for a random period of time. Then the chosen random from a fixed interval, they try to avoid this split elections. So by increasing the chance that a single follower will detect the loss of your leader before the others. And another important part is once selected as a leader, they have to create the log replication. So, how it is going to be created and how that will be shared with others, we'll try to discuss in the next class. Okay, as my system is also going for lower battery, I'm sorry for that. So, if you have any questions, please ask me.